So our rate of change is going to allow us to talk about what's happening to the graph. It's exactly the same idea as when you were in algebra and you would get a straight line and talk about the slope of a graph, right? And you would tell me the slope is positive or the slope is negative or the slope is positive 5. So it's the same kind of concept. It's going to mathematically look very similar. It's just that we can't say any graph has a slope because slope is only for straight lines, because slope is continually the same thing over and over and over. And we're going to be looking at graphs like the ones we've been doing domain and range, where they're all kind of squiggly and they're crazy looking. So they don't have the same change over and over. They're changing differently as we travel along. So we call it the rate of change. So if I were you, I would write down to remind myself that rate of change is the slope between 2 points on a function. Slope between 2 points. Do you remember the formula for slope? Okay, so y equals mx plus b is the formula for a line, but then there was a way to find slope between 2 points.
M equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2?
Yes, so if we wanted to find slope, we said m equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2, where you took your y values and subtracted them over your x values and subtracted them. And it didn't matter, you just had to pick any 2 points on the line because the slope was going to be the same over and over and over. The only difference is now we're talking about any function. So we could have a linear equation, but we could also have a quadratic equation, we could have a cubic, we could have all sorts of things. We could have any of those graphs that are up on that front wall. So when we want to find the rate of change, they're going to have to ask you to find it between 2 specific points because it's not going to be the same everywhere. So when they ask you to find the rate of change, the formula you're going to use, rate of change, is f of a minus f of b all over a minus b. This is where the magic is going to happen today. Now, all I did was take my fancy slope formula. My y1 is the same thing as saying the y value at a. Y2 is the same thing as saying the y value at point B. X1 is my point A specifically that they're telling me. And X2 is my point B. So it's mathematically, you're not going to be doing anything different than you were with slope. You're going to be taking 2 points, subtracting the y values, subtracting the x values, getting the slope. We're just, since we're fancy mathematicians now and looking to, really be snazzy with our math, we're not going to call it slope because that's technically not what we're talking about. We're just talking about how there is a change between 2 specific points. So all they did was take your slope formula and give it fancy new notation and a fancy new name. So the physical math today should be pretty straightforward. Are you ready? All right, cool. This is where the sticker part is going to come in. So I can ask you to find the rate of change giving you a graph. Anytime they're asking you to find the rate of change, they have to give you 2 x values because they have to ask you where you're going to find the rate of change because I'm going to get different slopes all over that graph. Some of my graph is going up, some of my graph is going down. I have positive slopes, negative slopes, I have 0 slopes. things are crazy over there. So it's not going to be the same everywhere. So they have to specifically tell you where they're looking for that average change so that you know what to plug into your formula. So if I ask you to find the average rate of change on the closed interval from -1 to 4. Now remember, if they're giving you an interval, these are your x values. This is your first x, this is your second x. That's not a coordinate anymore, it's an interval. So they're saying start at -1 and end at 4. So they're telling me they want me to find the average rate of change from -1 to 4. So now I can see that the graph kind of goes up and goes down. It's changing all sorts of different ways from -1 to 4. But I just want to know, on average, what's happening. So when I'm finding the average rate of change, what I'm really finding is the slope of the secant line that connects them. Secant is the fancy word for line that connects any 2 points on a graph. That'll show up more when you're in calculus. But basically what I'm doing is I'm taking a big giant function, I'm picking 2 points, and I'm finding the slope between those 2 points when I'm finding the rate of change. So now my rate of change formula tells me to take f of a minus f of b over a minus b. And they already told me I have my first value and I have my second value. My first value is -1. My second value is 4. So all I'm going to do is go into my rate of change formula, replace my a's with -1s, and replace my b's with 4s. So I end up with f of -1 minus f of 4 all over -1 minus 4. And just like with your slope equation, it's super important that you line up your x values and your y values. So I have to make sure if I started with -1 in the numerator, I have to start with -1 in the denominator. I can't flip-flop them. So now I need to find f of -1. Do you remember how to do that? F of -1 is just asking you what's the y value when your x is -1. -3. So all it's asking you in this situation, because they're giving you a graph, is to go over, look at the graph, find the y value when your x value is -1. And my x value is -1 is right here, which gives me a y value of -3. So I'm going to replace f of -1 with a -3. Minus, now I also have to find f of 4. F of 4 is -1 because that's my y value when x is 4. So I plug in -1 over, my denominator is going to stay the same, -1 minus 4. And then at this point, I'm just going to simplify because now I just have numbers. I'm going to take -3 minus -1. -3 minus -1 gives me what? -2, right? Over -1 minus 4, -5. So my average rate of change is really 2/5. My average rate of change from -1 to 4 is 2/5. And I can kind of check myself when I look at the graph because 2/5 is a positive number and I can see that I'm going uphill slowly from -1 to 4. So that's good. I have a positive slope. I got a positive rate of change there, so I'm looking good. If I had gotten a negative number, I would have known I probably messed up a sign somewhere, and I could go back and check myself. Since that is going up, it should be positive.
When it's like factor, isn't it y over x? Or is it x over y?
It's
Why is it a factor?
Y over X.
Y over x.
Got it.
All right, what if I gave you the same graph, and I said find the rate of change from -3 to -1? Try that one. -3 to -1. So same graph. If you can fit it on the same page next to the graph you just did, go for it. Same graph, -3 to -1. If I were you, the first thing I would do is write the formula down. And then go and plug into the formula and simplify. It's a good habit to get into, just writing the formula down, especially if you plan on taking AP Calc next year, because when you take AP Calc, the actual exam has open-ended questions on it, and you can get partial credit, and just by showing them that you kind of knew what the question was asking and knew what formula you were using, gets you partial credit on some questions, so it's a good habit to get into.
Did I do that?
Like, so the first thing you wrote down, formula, f of a minus f of b all over a minus b, where a is the first number they're giving me, b is the second number they're giving me, so then I'm just going in and plugging in, right? So now I have f of -3 minus f of -1 over -3 minus -1. Minus a negative is really positive, right? So I can change that to a plus sign.
Could you parentheses
The -1? Absolutely. What is my y value at -3? What's f of -3? 2. What is my y value at -1, or my f of -1? -3. And then I have -3 plus 1. And then I'm just going to simplify. 2 minus -3 is like saying 2 plus 3. Gives me 5.
Excuse me?
Yes?
Your attendance didn't come through?
Oh, sorry.
Thank you.
And then -3 plus 1. -2. And if I check myself, just to see if I kind of know what's going on, if my answer is in the ballpark, if I'm finding the average rate of change, I'm finding the slope of that line that connects those 2 points, which is definitely going down, and it's definitely going down pretty quickly. So -5/2 looks like it should be right. Not too bad?
You got that 2 from the y value?
Yep. The y value. That's all that f of -3 and f of -1 are asking. They want your y value.
So you don't,
Oh, so you don't
you don't include that part in your answers, that's just showing you
Mhm.
that
That's
expression.
showing how to get the f.
Exactly.
Oh.
Yep. That's all that's asking is find the y value at this point. Find the y value at -1. So we don't need that in our answer. Our answer should just end up being straight numbers.
plug in, to make it like easier, if you were to plug in the y's, so
Mhm.
like 2 as f right there, and then drop the parentheses, wouldn't that give you the same number? I didn't do the math, I'm just asking, so it
So-
make it quicker.
Once you plug in the y value, that f shouldn't be there anymore.
Okay.
Because that f is like the fancy math notation for saying what is the y value. Instead of us physically writing out all the words, what is the y value at -3, f parentheses -3 is the math notation for asking that. So once I actually physically put in the y value, I don't want that f anymore. It's gone.
Wait, why is the 5 positive if it's going down? Or is it going to the
Okay, so even though the 5 is positive, the 2 is negative, right? So when I'm dividing those, I can rewrite this fraction as 5 over 2 with the negative out in front. Or I can even write -5 over 2. They're all the same. It doesn't matter where I put that negative because there's only one, so the whole thing is negative.
If we just did y lower run and counted down the graph, what we consider the graph
It
already?
would-
Finding average, though,
if-
it's not a set slope.
If you had a graph, but you're not always going to have a graph.
Okay, so if you don't have a graph, we do that.
Yeah.
If we do, we can just.
Yeah, if you had a graph, you could. So then I could give you a table, and I could say find the average rate of change on the interval 0 to 2. And if I ask you to find the average rate of change on the interval 0 to 2, I have to give you now a table. In my table, I'm going to say, okay, I have -1, 4, 0, 3, 1, 2, 2, 5, 3, 0, 4, 1. So in my table now, I don't necessarily have a graph. If you wanted to, you could graph it to kind of get an idea of what's going on, but you don't have to. So if I want to find the average rate of change on a table, all I'm going to do is the same thing I've been doing. So write down my average rate of change formula, my f of A minus f of B over A minus B. And then I'm going to plug in what they told me. They told me my A is 0. They told me my B is 2. So when I go back to my equation, I get f of 0 minus f of 2 all over 0 minus 2. And now they're still asking me to find my y value at 0. They're still asking me to find my y value at 2. The only difference is instead of physically giving me a graph to read off of this time, now they give me a table to read out of. So f of 0 is just asking me, find my x value of 0, which so then I go and look at my table and I say, okay, here's my x value of 0. What's my y value when x is 0? 3. So now I replace this whole f of 0 with a 3. Minus, now I need to find f of 2, which is my y value at 2, so I find my x value of 2. My y value is 5, so now this whole thing gets replaced with a 5. I'm going to bring down the rest of my formula because I already have numbers there. And then at this point, I'm just simplifying. 3 minus 5 over 0 minus 2. 3 minus 5 gives me -2 over 0 minus 2 gives me -2, which simplifies to be 1. Right? The negatives go away because they're both negative, so 2 negatives cancel when I'm dividing. And then because it's 2 over 2, I have my entire fraction simplifies to 1. So my slope there is just 1. Not bad? Okay. What if I spiced it up and gave you just a function? If I hit next, is anyone going to panic?
We are gonna probably just write in
Okay. So whether they give you a graph or they give you a table, you're just picking out your y values to plug into your formula. If I give you an equation now, it's going to make it a little bit trickier because we're going to have to find your y values. So if I gave you the function f of x equals to quantity of x minus 1 squared plus 3, and said find the average rate of change from -2 to 0. So I'm still asking the same thing, but instead of giving you a graph or giving you a table to pick your values out of, I'm giving you an equation. So I know I'm going to need f of a minus f of b all over a minus b. I know my a is -2. I know my b is 0. So then I'm just going to plug in like I have been. I get f of -2 minus f of 0 all over -2 minus 0. So now here's where my algebra comes back in, because I need to know f of -2 and I need to know f of 0. In order to find f of -2, I'm going to go off to the side because I need to actually physically plug -2 into my equation and simplify. So I'm taking that equation that they gave me, the 2, and I'm replacing my x's with -2's. So all I did was take the function they gave me and substitute a -2 in for my x. I've got to simplify that until I get a number, and then that's my y value to plug back into my rate of change. So now I've got to use order of operations and do inside the parentheses -2 minus 1, -3 squared plus 3. Then I've got to do -3 squared, gives me 9, plus 3. 2 times 9 is 18, plus 3, 21. So I'm going to need 21 to go back in to f of -2. So where I had f of -2, now I have a 21. I also have to find f of 0. So I'm going to do it all over again, but this time I'm going to have a 0. So then I do 0 minus 1, gives me -1 squared plus 3. -1 squared is just 1. 2 times 1 gives me 2 plus 3. So I get 5, which means in my equation now I have minus 5, and my denominator stays the same. And then I just simplify. 21 minus 5 gives me 16 over -2 minus 0 is -2. Yep, which gives me -8. Bam. What do you think?
I think
That's as tricky as it gets. Not bad.
I think that's easier. It's just
Yep.
more work.
It's more work, but it's more algebra like you're used to, kind of, right? And less reading of graphs.